So exponents and logs kind of go together, and that's the main thing for today, is teaching about how exponentials and logs kind of go together. One of my students, when we were just talking about this before I started, said, yeah, aren't they inverses of each other? And that's an exponential. Do you guys remember that that's exponential growth? You know, here's x, y axis, and then here's what a log looks like. If you graphed it, a log looks like that. And those two are inverses of each other, because if I put in the line y equals x, it would run like right through here. I did not obviously graph this perfectly, but I think you get the idea. What's the red one again? Exponentials. What's the blue one? Logs. Okay. So if I was going to give you a simple one, I'm going to use base e because you're at honors. Log y equals log base e of x. And in case you forgot, e is about 2.718. It's one of those weird numbers that goes on forever and never repeats, kind of like pi. Okay, so e is just a always flat number, just like pi, where you just kind of put the e in there, but you know it's actually a decimal that goes on forever and never repeats. And then this other one would be, oh wait, I just did that wrong. The red one should be down here, sorry, just move it. You guys can do your little lasso tool, and log base e of x goes down here. Sorry, the other one is e, and somebody want to say it? E to the x, good. Okay, so there's exponential versus log. So, if I was going to ask you for the domain and range of this, do you get the red one's domain? It'll go forever in both directions for domain. You know, looking at the red one, do you get it goes forever this way and forever that way? Its domain is all reals. Is the domain of log all reals? No. If you can't see this, this is an asymptote kind of situation. It's going straight down. It's trying not to touch zero. So it doesn't go forever. It goes to there, and it goes forever in that direction. So the domain of this one was all reals. That means the range of this one is all reals. Does that ring a bell? The domain of the one function becomes the range of the other. This one, the blue one, goes forever in both directions this way. Okay, so the domain of the red one becomes the range of the blue one. They're both all reals. Domain and range, you know, domain of this one and range of this one are all reals. How about the range of the red one? Does the range of the red one go forever in both directions? Nope. The range of the red one only stops right here. It's like it won't go any further past zero, and then the range does go up forever. So the range would be from 0 to infinity, whereas the domain of this one then stops right there. Won't go past that. Goes forever in that direction. So again, domain and range are flip-flopped. The range of the one becomes the domain of the other. Okay, so there's the big picture. That's why when I write out this equation and say solve it, y equals 5 to the x, instead of just saying solve that, that's got an infinite number of solutions. Like when x is 1, y is 5, and when x is 2, y is 25. I don't want to really do that. I want to say 5 to the x equals like 8. That makes you see the need for a log. Now, I could do one of my favorite things to solve this. Factoring? No. Clearing the fractions? No. This is the least used, but very powerful. How could I solve this at this point? And don't say change it to a log, because yeah, that's what we'll eventually do. But how could I solve this without having to do anything super fancy? Okay, so you guys have forgotten it, and I understand. If you graph both sides, you can see where they cross. It is amazing to me how often we forget that you graph both sides, you can see where they cross. Y equals 5 to the x, I could graph that. and y equals 8, I could graph that. Let's kind of just look briefly at what that would look like. Here's what 5 to the x would look like. How steep it is kind of depends on how big the base is, but that's kind of an exponential, right? Okay, and then y equals 8, that's a line that runs like this. Do you get that they cross? And when they do cross, do you get that that's the answer? Okay, so we could do this by graphing both sides and seeing where they cross. I just wanted to take that moment to remind you because I knew that, I didn't know nobody would remember, but I knew that very few people would remember that you can graph both sides and see where they cross. That's coming up on one of your next tests. It wasn't on your last test, but it might be on your next one. Okay, so, or it might be on the one after that. So anyways, we're going to get to problems where the only way to really solve it is to graph both sides, see where they cross. But this one can be solved by rewriting it as a log. So everybody please underneath it write log. And then logs have 3 little parts to them. They have a base, the argument, and the last part is called the exponent. And yes, clean sweep there. Sam, nice job. So the way you read this, I don't want you to sound, do you get it sounds like people don't know what they're talking about if like an old person says, I can't find the Wi-Fi. It's like, it's not Wi-Fi, it's Wi-Fi. Right? That's so obvious that they don't know what they're talking about. They say Wi-Fi. Well, same thing. If you don't know how to say a log, you sound like you don't know what you're talking about. So I'm going to say this right, and you see if you would have said it right. Log, here the base is this number. And then you never go in order. So the next thing cannot be the x. Therefore, it must be the 8. And then the last thing is the x. Remember how I said it was the exponent spot? See, the exponent drops in right there. And notice it did not go in order. It wasn't 5 and then x and then 8. It was 5 and then 8 and then x. I like to think of that as kind of the circle of logs. You've probably heard of the circle of life. But this is the circle of logs. It goes like that. And when they get more complicated, you got to remember, okay, I go to the other side, and then I come back to the exponent at the end. So now how do you say it? Like I said, if you were saying Wi-Fi, it clearly means you don't know what you're talking about. That's Wi-Fi. Well, this is not log 5, 8. Log base 5 of 8. Log base 5. And you have to say these words, otherwise you don't know what you're talking about. You don't say log 5, 8. You say log base 5 of 8. And then this last part, you could certainly say equals, or you could say is. I think it's actually more common to just say equals, but log base 5 of 8 is x. Get how to say that? Okay, so then why is this better than what we had in the first place? This, to me, looks like a math problem. And for many of you, this probably looks like a math problem too. But to me, that is an exact answer. That's an exact answer because log base 5 of 8 is something I can look up. Just as if I had said like 2 to the 3rd power. Like, I happen to know that one in my head. But if it was like 2 to the 43rd power, well, that's just a number I can look up. This is a number you can look up. You can figure out what that is exactly. Now, if I use a calculator, the problem is it won't be exact. I know you're thinking calculators always give you exact answers. Nope, they give you rounded answers. Do you get that this decimal, the decimal that would be 5 to the what power equals 8, that's not something simple like 1.2. It's going to be a decimal that goes on forever and never repeats. Okay, so it's kind of interesting. 5 to some power, would it be 5 to the first? No, it has to be bigger than that. Would it be 5 to the second? No, it can't be that big. So it must be 1 point something. Well, it's actually 1 point something that goes on forever. All right, so we're not going to get an exact answer like the answer is 1.2. The answer is like 1.2735498 whatever, and you have to round it. So this is what's called the exact answer, it's right off your test. Answer must be exact. That means you better not use the calculator and go get a decimal for it, because the decimal will be rounded and therefore not exact. But all that being said, I'd love to actually figure out what is log base 5 of 8. So here's how you would do it. If you have your graphing calculator, bust it out. If you don't, then you're going to have to figure it out on your iPad. If you go to my yellow folder on my website through single sign-on, you could get a graphing calculator that way. All right, and if you've got the new operating system, which many of you will have, if you hit math and then alpha and then math, there's a math button, and then hit the alpha button and then hit the math button. Math alpha math will bring up a little thing that goes like this: log with a little box and another little box, and that's where you put in log base 5, and then you put in a little box, you put in 8, and then you hit enter, and it tells you. So everybody right now, do your best. By the way, this is not critical that you be good at putting these in a calculator, because if I remember correctly, your next test doesn't allow calculators. So how on earth would you get the answers? Well, you'd leave the answer exact. And the answer would have been log base 5 of 8. Boom, done. But can you tell me what the decimal is, Mr. T?
1.2920296.
Good enough. Would you agree that that would round to about 1.3?
Sure.
So then, if I'm going to round it anyways, may not make it a complicated number, so 1.3. Do you get that means that 5 to the 1.3 power would be about 8? Would it be exactly 8? No. To get it exact, you would have had to use that log base 5 of 8. Okay. Yes?
So the log button on the calculator, what base is it in?
Good question. If it just says log and it doesn't have a base, you want to answer? You've known every other answer so far.
The argument divided by log of the base.
Okay, just stop for a second. All she asked was, what's the base if there is no base? It's really simple. If they don't say a base, that means it's base 10. Okay, so they're doing base 10. If it just says log on your key, which it does, there's a key that just says log, that implies base 10. And that's called the common log because it's the most common base. If I had said, everybody make a guess, what do you think the base is going to be? Most commonly, you'd probably say base 10. A lot of the stuff we do is base 10, right? Okay, so log base 10 is the one they mean if they just say log. By the way, there's an ln key on your calculator since you have it out right now. Do you guys know what that means? Yes. Yes. That exactly translates to, and I want you from now on, from now till the end of this unit, whenever you see ln, I want you to write log base e. You'll see why later, because there's no base written here. And usually in logs, just like Megan Trainor said, it's all about the base. Okay, so anyway, that's log base e. So whenever you see ln, that means log base e. And that's that number that goes on forever and never repeats. All right, so there's a bunch of base stuff. Let's see if you've been paying attention for the last 13 and a half minutes. And if I say 5 to the, I don't know what, equals 14, would you please change that into a log? I want the answer as a log. And it'll be exact, unless you go to your calculator. You've got to break that misconception that everybody thinks calculators are somehow more accurate. They aren't. Calculators are good at finding approximations, because for decimals that never repeat, they have to stop somewhere. All right, Haven, what log did you think this was?
Log base 5 of 14
Oh, you even said it right.
is X.
Perfect. Log base 5 of 14 equals x. Good. That's the exact answer. All right, now I have to get you into going backwards. So what if I said log base 3 of x equals 4? You should be able to rewrite that the other way. Like as something to a power equaling something else. Would you agree that this part is called the base? Which of these three things looks like the base to you? I'm going to call it A, B, or C. Which one feels like the base? A feels like the base to me because it's the base of something that has an exponent on it. So I'm going to put that 3 right here. And then you always go up in the circle of logs. 3 to the 4th, remember this is the exponent spot, equals x. If you always keep that circle of logs going where you go over to the other side of the equals and come back, even when the problems get more intense, like log base x plus 4 of square root of 5 equals 7, if you keep the system going, you're going to go, okay, what's the base? That's the base. To the other side, that's the power. Back here, square root of 5. And that actually isn't that hard to solve. How would you get that to the power of 7 off of there? Put it to the 1/7 power. And then you'd have x plus 4 equals square root of 5 to the 1/7 power. Yep. Square root of 5 to the 1/7 power. If you wanted to simplify that, I could. I could say that's 5 to the 1/2 power to the 1/7 power. Okay, but let's not hurt people's brains too much. I got x alone. Yay. That is an exact answer. Do you get as soon as you put it in the calculator, you'd have a rounded answer? We deal in exact answers in this unit. Last thing I'll do is for the extra smart kids, square root of 5 is really 5 to the 1/2 power, which is then put to the 1/7 power. And then I subtract 4. That's the same as 5 to the 1/14 power minus 4. That would be the simplified final answer. Okay, that went a little beyond what we have to do today, but I'm just trying to show you kind of where we're going and why logs are related to exponents. And if you can take this though, log base 3 of x plus 5 is equal to 7, and rewrite it, we know you're on a good path right now. I'm going to put that in parentheses. A lot of times they do that for the argument part of the log. They put it in parentheses. Would you please rewrite this as a power? Something to the something equals something. And then I want you to compare it with the kid next to you. Don't solve it. Just put this as an exponential. Something to the something equals something. All right. Now compare your answer with the kid next to you. Eric, can you work with the kid next to you over there diagonally? Thank you. Okay, so which of these three is the base? Well, that's obvious. And then you start with the base, and then you do the circle of logs. 3 to the 7th equals x plus 5. If I asked you to solve it now, it'd be like, well, that's easy. Subtract 5. And you're right. That's it. 3 to the 7th, some ridiculously big number, minus 5. Okay? All right. Feel like you're getting it so far. Now, here's a few things about logs that you have to be good at. Charlie, data phone. Don't let it come out again. This is x, but if I say log base x of x, I already know what the answer is. Because if those two are the same, it simplifies super easy. This and this are the same. Do you know what the answer is? 1. Okay, so you should know that pattern, that if those two are the same, then the answer is 1. So if I said log base 5 of 5, the answer is 1. But I'm going to tell you why the answer is 1. Because, would you agree that log base 5 of 5, the 5 here has a little 1 in its exponent. Would you agree with that? Okay. And if I don't know what it's equal to, I could say it was equal to x. Do you agree so far? If I didn't know that the answer was 1, I could say that that must be an x because it's unknown to me. So then I could rewrite it. And I could say 5 to the circle of logs, x equals 5 to the 1. Do you see why x has to be 1? Does that make sense to you? 5 to the x had to equal 5 to the 1. So then if the bases are the same, these two must be the answer, and x must be 1. All right, so I just said something that's really critical. If the bases are the same, then the answer, the way I usually say this is the answer's already there. If the bases are the same, the answer's already there. So I'm going to say, let's say it was log base 3 of 3 to the 4th. The answer's already there. What is it? 4. The answer's 4. If you want me to do it the slow way, I'd go like this. 3 to the x equals 3 to the 4, and then it becomes pretty obvious that x must be 4. So if the bases are the same, the answer is already there. Do you get, then you oftentimes want to try to make the bases be the same. You aren't on a cell phone too, are you? Oh, no, you're not. You're just looking at your hands. Okay, good. So here's another one where the bases aren't the same, but you could make them the same. Log base 2 of 8. They don't have the same base, but they could. McLean, what could 8 be written as that would make it so the bases are the same? Exactly. So as soon as I change this to 2 to the 3rd, then the answer's already there. What is it? 3. If you type this into a calculator, the answer would be 3. Why? Well, watch me rewrite it. 2 to the 3rd equals 2 to the 3rd. See? Circle of logs. All right. So then, there's so many properties, and I got to stop myself from just riffing on properties all hour because there's so many of them. And eventually you'll have to use tons of properties. But let me give you another couple that are kind of a big deal for today. Log base 2 of negative 1.6. You may know the answer. Of course you wouldn't in your head. But could you just type it in the calculator? Sure, but I don't even need to, and I can tell you the answer. There is no answer. You can't have a negative argument or base. Neither the base nor the argument can be negative. Okay, so there's just no solution. If the argument or the base are negative, there is no answer. So a lot of times what happens in here is you end up solving this complicated equation. I don't even want to finish it, but you've solved this thing, and you end up figuring out that x must be negative 2, and you don't even notice that that's not even legal. Do you get, if the answer came out to x is negative 2 at the end, that's called extraneous? Because you can't have a negative base.
Why?
You also can't have a negative argument.
Why can't the base be negative?
Why can't the base be negative? Okay, so let's set up one where the base is negative, and I'll show you the craziness that results. Let's say I said that base was negative and we could solve for x. Then what we have to do is go like this. Negative 1 to the 4th equals x. And the problem isn't when your answer is like this. Okay, I set up one that actually you theoretically could get an answer there. The problem is when you have a normal number, let's say here. I should have set it up the other way. Let's erase two little things. Let's erase the 4 and erase the x and make this a 2 and make this the x. So then it's negative 1 to the x has to equal 2. Now you tell me, what could I put negative 1 to the power of that would make it equal 2?
Nothing.
It's impossible. That's why you can't have negative bases.
I mean, if it was like 1 though.
Could you set it up so that it could work one time?
Yeah.
Yes, but that's a little like saying this. All you got to do is take this number times this number and you get the answer. And you might be like, that doesn't almost ever work, but it works one time. you could make it so that this times this equals the answer. Only when x happens to be 2, then yeah, it happens to work. And you'd be like, but that's not the way it goes. That's not how it works. But you could set up one of them that would work. Same idea here. You could theoretically set up a problem where -1 could be the base, but it wouldn't work for anything else. All right. So there's one more property. We have to stop the questions. I'm sorry. I know this is interesting and it's cool, but I have to get to the end. So here is a typical question that goes with that. Wait. I don't want it so I can solve it. I just want that. That's called an expression. Doesn't say equals, so it's not an equation. Okay, so now here's my question. What can x be? Anything I want? No. Could it be 1? Would that be legal to have a 1 there? Yes. Could I have a 2? Yes. Could I have a -4?
Yeah.
But could I have a -5? You can't have base 0. If I never said that before, it's not only negatives, it also can't be 0. So, bottom line is, if you're asked for the domain of this, you would say, hey, x plus 5 needs to stay greater than or equal, no, not equal or equal to, greater than 0. Because that's what we know about these, is that can't be 0 or negative. And this also, the way it's easier to say is that has to be positive. This has to be positive. There's another exception, but I don't want you to hit me with all the exceptions right now. Do you have a question, or are you going to give me an exception? Okay, I don't want to just confuse people. I know I'm being overly generous or vague right now about there's some weird exceptions to the rules, but you got to teach people the rules first, and then you can teach them the exceptions. You know, like you have a little kid, he's going to cross the street, you say, don't go in the street. And then later, when they're older, you can say, okay, well, you can go in the street, but only after you look both ways. Then you can go in. So right now I'm teaching the general things that this has to stay greater than 0. And I know it's more complicated than one more thing. It can't be, but don't want to teach that today. So you're not ready for that. So if I had to solve this, I'd just say x has to be greater than -5. And that would be my domain. All right. There is one other exception, but I don't want to talk about it right now. Okay, this number also needs to stay positive. So if I had a problem like this, log base 3 of x plus 7, this part has to stay positive. So what do we set? Then x plus 7 needs to stay positive. How do you write that in math?
X plus 7 is
Greater than 0, good. And then you would solve it. So x has to stay greater than -7. That's the domain for this function. You can't let these ever be negative or 0, so they have to stay positive. This has to stay positive also. Yes?
For the base, couldn't it also not be 1?
Yep, that's the exception I don't want to talk about right now. Okay, so wait. Did you just say the answer can't be negative?
No, for the which Andrew said the exponent could be negative and it would work for the last one.
Okay, again, I know this is good that you're hitting with all the exceptions, but what I've written right here for this answer, this is the correct answer for the domain of that one. Okay, and so let's not try to hit every exception. We're never going to get through the lesson. So yes, I'll teach you more about further exceptions later. All right, so if I asked you log base 5 of x to the 3rd, and I said, what's the domain of that? Everybody figure out what the domain of that is. What do you set x to the 3rd? Greater than 0. Can you solve that? Sure you can. You put it to the 1/3 power, and x is greater than, what's 0 to the 1/3? 0. X has to be bigger than 0. That's the domain. Okay. All right, so that's how the assignment ends. There's one more little property that I want to teach you. Log base 3 of 1. Anytime there's 1 there, then I know the answer already. But for right now, let's say I didn't know the answer. You're always allowed to say equals, I don't know. Nothing wrong with that. You just have to solve it then. And then you go 3 to the x equals 1. 3 to a power equals 1. What power would make that happen? 3 to what power equals 1? 0. Anything to the 0 power will be 1, right? So I have a snappy little saying for this. If you've won the argument, you get nothing. The answer is 0. If you've won the argument, you get nothing. It's also true in life. You and your friend might argue about politics. I have a good friend, and he and I have different views on politics. We're good friends. If we argue about that kind of stuff, we might end up winning the argument like, I pounded him into the ground, and now he just hates me and I've got nothing. It's stupid. You shouldn't, win an argument and then get nothing out of it. You and your friend, you're arguing about, it doesn't matter. It could be even about pizza. I've had the most ridiculous arguments with people sometimes. And I can even prove that I'm right, and then I get nothing out of it. It just hurts me more than just letting it go. So just learn that you don't have to always win arguments. Sometimes you won the argument and you get nothing. Okay, so if there's ever a 1 there, the answer is 0. I mean, if there's ever a 1 there, log base x plus 7, and it looks really complicated, and then there's a 1 here, and then boom, I know the answer. What's the answer? 0, because they put a 1 in the argument spot. The answer must be 0. Okay, feel like we're ready to get into the homework. So everybody right now, zip the end of the file. I know I skipped over a lot of stuff, but man, there's a lot of stuff. So let's go through some of the problems in the homework. Here we are in the assignment area. All right, well, there's a lot of different things you can do with logs. One of them is to write them back and forth from exponentials to logs. Do you recognize that this one is not a log? There's no word log, so it must be an exponential or an exponent problem. Then I can take any exponent problem and write it as a log problem. So let's take this and write it as a log problem. Log, and what's the base? 5 of, where do we go next? Circle of logs. Of 1 over 125 will equal -3. Now that is a fact. And it also means, from what I told you before, do you remember if we could make these bases the same as each other, then the answer would be the exponent? Do you get that leads you to know that this right here must be 5 to a power? Do you get where I'm going here? That has to be 5 to a power of what? -3. Well, what's 5 to the third? 125. What's a negative power do? It makes it 1 over. So it is. This is the same as 1 over 125. Now, you don't have to write all that. Your only job here was to make it into a log. I'm just showing you that that implies something else about 1 over 125. It could be 5 to a power of -3. All right, this next one. How do you rewrite this as a log? Well, let's cut this down to be a more reasonable size. Sometimes there just isn't enough room to do all of them. So I'm going to recommend that you chop out this one to make more room. Oh, I should have scribbled instead of highlighting. Chop out that one. Let's chop out this one. I don't really want to skip number 6 because that kind of thing comes up all the time. And number 9 is really good too. We're going to chop out 15. And I think you should do the rest of those. These are all things that could come up on your test. So how do you do number 14? It's a log. You didn't show us what to do there. You make it into an exponent. So I said whenever you see ln, you should say log base e of e equals 1. And now it makes sense. Because see, the base And the argument, they're the same. The bases are the same. The answer's already there, and it's power of 1, so it's 1. So it makes sense to me. Does it make sense to you? But the problem is I haven't rewritten it. It's a log still. So I got to rewrite that and make it e to the 1 equals e. And you could just put to the 1 if you wanted. There, we rewrote it. It doesn't have logs anymore. So that's kind of the key on this whole page, is if it doesn't have logs, make it have logs. This one's log base 4, and then you finish it. And if it does have logs, rewrite it so it doesn't have logs. Right on this page, there's a whole bunch more like that, and this is just like obscene. I'm just gonna have you chop off this whole second set here. But I think once you get the hang of these, they'll go fast. So like here, you could write 27 as 3 to the 3rd. So what's the answer? Base is the same now. Answer's already there. 3. You could write this as 6 to a power. You might be tempted to say 6 squared because that makes 36. But then you got to get it to be a fraction, so it's 6 to the -2. Now I know the answer. It's -2 because I made the bases the same. This must be able to be written as 1/5 to a power, but I don't know if you're smart enough to figure it out. We got to get 625 to shrink down to 5. 1/5 to the power of... It's not a negative because it's not... Oh, wait, it is flipped. It's negative something. Don't say it. Don't say it, please. Let people figure it out for themselves. If you figure out this answer, then you'll know the answer, because the answer is, now that we got the bases the same, the answer would be the power. So you just have to figure out what power that is. Use a calculator if you have to do the grunt work math. This one, it has no base. So what's the base? 10. And then this could be written as 10 to a power, couldn't it? And then they'll have the same base. Hint, it's 10 to a negative power because it's got that 1 over it. All right. You should definitely do that page. Now this page, domain. Do you remember me saying that this part right here had to stay positive? So this is super quick. You just go 4x plus 8 needs to stay positive. How do I write that in math? Needs to stay positive. Greater than 0, and then you solve it. All right, challenges are always not required. Ooh, this one's got factoring. You should definitely do that one. This one's got factoring. You should definitely do that one. We're going to skip this one. I already started this one, so you may as well do that one. You know what? We'll just do this. We'll cross off the whole right side, and you do the left side. Kind of keep a theme going, chopping off the right side. Okay. There's a reasonable set of practice problems to do to get better at logs. And that's all I got for you on that for today.